खोलो गरम है फिर अरे थोड़ी सी भी ज़्यादा नहीं गिरी इसको पकड़ो पानी पूरी नहीं खाया दही पूरी खाया में मैसे और मुझे पता था पानी पूरी बनाओ मुझे अच्छा भी नहीं लगता और पानी पूरी और मैंने खाया ज़्यादा नहीं खाया साथ साथ इसलिए और पानी दही पूरी खाया 2-3 छोटे छोटे बिस्किट है नाम क्या होगा पानी पूरी हैवी होता है तो तुम 8:30 बजे तक जाए कि नहीं जाए भूख नहीं रहेगा तो नहीं क्या करने जाओगे जगह ही नहीं है भूख लगे जितना मांगे उतना खा लिया कौन आ गया क्यों आ रहे हो मैं जो लगे वो ऑर्डर भूख नहीं लगता 8:30 बजे तक नहीं लगेगी अभी 6 बजे 2.5 घंटा कहाँ जाए मुझे पता नहीं वो कैसा भूख लगना चाहिए जगह बताता हूँ उसका नाम नहीं बताऊँ आज से बहुत महंगा चलो कोई बात वही वाला है नहीं देखा पर मैं माता की मार्केट में गया बहुत है कौन सा कौन है वो भी नहीं पता मुझे एड्रेस में दिया होगा पर मैं देखा नहीं कैसा टाइप का कुछ नहीं पता जाओ राजधानी एल्बम खरीदा जाओ ना ₹150 का
यार वो महंगा है वो। मैं ये नहीं बोलूँगा कि नहीं जाओ, बट ये भी वर्थ नहीं है ना वहाँ पे करना।
क्यों? और ऑफर होगी तो
ऑफर होगी है कुछ तो ठीक है। कितना परसेंट? लेकिन मेरे को मैं गया हूँ इसलिए मैंने बोला हाँ।
50।
सच में कितना भी खाओ,
जितना भी खाओ मतलब वो थोड़ी नहीं है, वो अपन जितना लोगे उतना बिल पड़ेगा ना, वो बफे नहीं है।
उसका हाँ वो
उसके 50%।
50%।
वो ठीक है।
कैसे पता चला तुम? बताओ यहाँ ले और सर्चिंग तो
मैं नहीं देखता
इसमें
क्यों डायरी
50% का मैं सही गेस किया ना?
तुम दूसरा भी खाओ तो
कौन सा?
वो रेन फॉरेस्ट।
नो नो, तुम्हें पता है रैंक वाले में बार बार फर्स्ट के साथ ये वाला यार हम लोगों ने 5 लाख से 10 लिया 300 400
वैसे होता है तो हम भी गए हैं, पर वो भी मुंबई गए रेन फॉरेस्ट में।
वहाँ पे लोग पीने जाते हैं रैंक फॉरेस्ट।
वो है पूरा वो बकेट का पैसा 50% ऑफ है, और HDFC होगा ना तो +50।
HDFC
और मुझे लग रहा है HDFC के वो ऑफर के लिए कुछ तो 2000 के ऊपर होने चाहिए। वो भी आई गेस आफ्टर 50% रिडक्शन, तब तो ज़्यादा
अच्छा हो तब मैं ले आता HDFC का प्रिया के पास से।
नहीं, मेरे उनके पास भी है, मेरे भाई का भाई है ना। हमें थोड़ी ना, हाँ ये लगेगा, हम तो डिटेल लगती है, वो तो ना कार्ड लगेगा, कार्ड का डिटेल डाल के कट होगा ना पैसा, टैप थोड़ा नहीं करते हम।
तो तुम अपने कार्ड से नहीं करा ऐसे
कर नहीं रहा।
क्रेडिट कार्ड से करोगे? लेकिन तो तुम भूख नहीं लगती
लगे सारे यार लगे
नहीं लगी
नहीं लगे तो
तुम भूख नहीं लगती।
कोई नहीं, फिर निकाल लेना तो हमारा।
और तो पी लो एक टोस्ट उससे भी अच्छा है मार्केटिंग देखो ना क्या ऑफर है राजधानी
चल उसको
पागल कुछ गया गया क्या मिलता है वहाँ पे बताओ? अरे क्या मिलता
एक नीचे ये ऊपर ले लेता तो ले लिया।
महंगा है कितना
कितना ही महंगा 2000 का भी थोड़ा दोनों का 1000 तो दोनों को मिला के
खाली रहेगा वो पता नहीं आज भूख लगी रहती है उस टाइम क्लास में ऐसे पानी भी यूज है ना मैं वो नहीं बोल रहा तो मैं कल रहेगा कि नहीं
पता नहीं
बताओ ना उसमें नहीं दिखाता
आज का तो दिखा रहा हूँ
कल मैसेज पहले भी देख रहे थे ना वो ज़्यादा बेटर रहेगा
कल तो ये है ना सेकंड में
आप नहीं देखो तुम बस
तो ऐसी बात नहीं है मैं आज मूड डाउन होगा अच्छा लगेगा
नहीं वो मैं अच्छा नहीं बोला
मैं थोड़ी ना नहीं
ओके
क्यों करता इनके फिल्म बता जाना होगा तो आयुर्वेदिक का ताकि सारा तक बात हो मैं तो ऐसा
ये था
ठीक है
जब मैं कराने से आता है तो उसके मुझे ग्रीन टी शर्ट पहनने के लिए मत बताते हो ब्लैक पहन मेरे साथ जा रहे थे कोई मुझे सॉन्ग ग्रीन पहन ब्लैक पहन
नहीं अच्छे इसलिए बनाने तो फिर से निकालो
मेरे साथ कोई
वो एक पैंट वैसे तो गंदी हो गई पीछे से तो निकाल ये हो तो उसके ऊपर शर्ट पैंट नहीं तो
ग्रीन वाला पहन लो ना
और किसके ऊपर वो गंदी हो गई पीछे से
नहीं
हाँ वो ही काला काला सच्ची
अरे बहुत बहुत वाला है
ग्रीन एक्चुअली टिपिकल इतना भी नहीं होता तो फिर पता नहीं मैं तो आगे भी थोड़ा एक्चुअली इधर है इसलिए नहीं तो फिर मैं पहन नहीं
Hello, good evening, everyone. I hope am I audible to everyone. So let's begin our today's session. So we have entered in our week 6 of the doubt and problem solving session in the course of carbon materials and manufacturing. So I hope that you have all watched all the lectures in module 6 so that it would be well helpful and easy to understand whatever the questions I'll be taking in this session. So let's begin with our today's session. So directly I would like to come to the numerical questions where you have to calculate the UV dose for a resist film of thickness 5 micrometer. Given the energy required for photoinitiation and cross-linking is 140 millijoule per centimeter square, and the intensity is also given of the UV lens, which is 7.5 milliwatt per centimeter square. So I would be giving you some times so that you can solve and you can give me the answers by unmuting yourself, as well as you can also type the answers in the comment box. So yeah, your time starts now. You can start solving the question. Yes. So, what is the answer? I hope you would be able to solve this. Okay. So, I think if not, then please do let me know. I'll try to solve these questions and I will discuss the same if you will have any problem. It's very simple. So, the next question is in the case of in a case of a positive photoresist, pattern on the mask is opposite of the desirable pattern on the mask is same as the desirable pattern on the mask is prepared at certain offset, pattern on the mask is prepared to accommodate shrinkage. So any guesses what could be the right answer for this? Hello, hello, am I audible? Hello, hello, hello.
Yes, sir, you are audible.
Yes. So you are the student for this course. Did you watch the lecture?
Yes, sir, yes.
All the lectures? Okay. So I was discussing this regarding the photoresist. So I hope you have attended the previous session, so you know that how we go. So the question is, can you see the slide? Hello.
Yes, sir, I saw.
So the question is in the case of a for positive photoresist, pattern on the mask is opposite to the desirable pattern or same as the desirable pattern or is prepared at certain offset or is prepared to accommodate shrinkage. So do you know what could be the right answer for this question which is regarding the photoresist? Yes, hello. So you can answer this. Yes, so the as you all know, the photolithography. So in photolithography, basically involves the patterning a structure by using a UV light onto a thin photosensitive polymer film. The polymer is known as photoresist, which can be of two types. So the first one is your positive resist, and the second one is your negative resist. So in this photolithography, there are five main steps. So the first step is your spin coating the resist film onto a substrate. Substrate, you can say a silicon wafer, and then the second one is a soft baking. So in this, we heat to remove the solvent. Third one is UV exposure through a mask, and here after that we do the post exposure back so that it can cross linking propagation can happen. Fourth one is your developing. In this, we remove the undesired parts. So first is the inspection under the microscope using the SEM electron microscopy. Here the negative resist cross-link, hence the structure on the mask should be opposite of the desired structure for positive resist. The structure on the mask is same as desired. So for the positive resist, the structure on the mask is same as desired. Yes. What is your question? How to find degree of graphitization calculation? So this is which week assignment question is it?
Yes, sir. It is an assignment question. I have doubt how to calculate that T0002. In that particular formula, I don't able to calculate the T002. Can you please explain how
It's
to calculate
week
it?
5 or week 6?
Sir, sorry.
Is it a question from week 5 or week 6?
Yes,
Yes.
yes, sir.
Week 6 assignment.
Yes.
Okay.
No, it is assignment number 5.
5.
5. The first question problem.
Okay. So let me just check whether that I have incorporated in my assignment that kind of a question or not. So I think it seems like I have missed that question to incorporate. So it is regarding the degree of graphitization, right?
Yes, sir. Yes. The
Okay.
answer they mentioned 190 to 210 range,
Haha.
but they does not mention in lecture about how to calculate that D002. That is entrepreneur facing.
Okay. So I'll try to see in the lecture that what is the formula and what is wrong that is given in the solution, and we'll get back to you in our upcoming class. Okay?
Okay, sir. Thank you.
Yeah. So can we begin with this? Do you know the photolithography?
Yes, sir.
Okay, yeah. So here I was just explaining the photolithography. So as you can see in the first, so you are a like masters or what you're doing?
Uh, I am doing a PhD doctorate.
PhD where?
Yeah. I'm doing in Anna University,
Huh?
Chennai. Chennai Anna University.
Anna University. Okay, yeah,
Yes.
yeah, yeah. Okay, okay. Yes. I think in your university there is I think one conference on 27, 28 if I'm right.
Actually, I am doing PhD under the Anna University. Actually, I am working in a financing institution, self-financing institution, engineering college.
Huh?
I'm not actually doing PhD in Anna University, sir. I'm just doing PhD under the Anna University. I'm actually doing part-time PhD in Anna University.
Okay, okay, okay. Okay. In Chennai.
In Chennai.
Okay. So you are from Tamil Nadu.
Yes, sir. I'm from Tamil Nadu.
Okay, yeah. Last week I went on one conference to Chennai actually.
Yes, sir. Yes, sir.
So yeah. So you are in which year?
Just now I joined, sir.
Oh,
First
now
year.
you. Okay, okay,
Yeah.
okay. Yeah. Yeah. So in photolithography, we do the spin coating and then we do the baking so that the solvent can evaporate. Then we do the UV exposure. Then we develop the film, and then we do here also some undesired part will remove, and then we do the inspection whether the pattern is right or wrong, or is it some misalignment is happened, or is it perfect. So for positive resist the structure on the mask is same as desired. Okay, so whatever the structure is there in the mask, same pattern we will get. So the question was asking the same thing. The for positive resistor is the, so your answer will be same as the desirable pattern. Okay, so have you seen the clean room?
Yes, sir.
Yes. So in clean room basically we do the photolithography. Okay, because so that any contamination should not occur in your film. Now here we use a cross linking. So you know what is cross linker? Yes, hello. Am I audible? Hello. Hello. Yes. So did you watch the lectures of week 6? All the lectures? Okay, yeah. So I was here. So could you answer this question? That in a case of positive photoresist, pattern on the mask is what, opposite, same, or something else, or it offset, or it shrink. Shrink. Are you sure? It is asking about the positive photoresist. You can also unmute and you can you see this slide here? You might get some idea regarding the positive photoresist, that how it could be. Now can you answer after seeing the images? This one is for the positive resist. This one is for the negative resist. So now can you answer this question? Yes. Question page. Okay. This is the question page. You can note it down. Option B, same. Yes, right. So in the negative you will get the opposite, but in the positive you will get the same. Okay. Now cross-linking. So there we use a cross-linkers in photolithography. So do you know what is cross-link or what is cross-linker? you might often have heard in a polymer chemistry or polymer physics, that the effect of cross-linking. So what is cross-linking? Yes. So the cross linkers, when we use the cross linker, the so here in this process, when we use a negative resist, then have a chemical structure that contains some additives which provide a proton after being exposed to the UV light. So when we expose to the UV light, it should have some kind of a cross linker. So during the post exposure, back the photon initiates a chemical chain reaction which creates radicals in its side chains. Okay, so that will then help for this cross linking. So these radicals bond with each other and the polymer chains are bonded sideways. So this is known as cross linking. So that's why we add a cross linkers. Now the resist viscosity and the film thickness, how we should optimize this. So the negative photoresist come in different viscosities. One can make up to 150 thick film with them, which means that can be the height of the pattern structure. But for the positive, resist are used for making thin films. Okay, negative for making device such as MEMS devices. Critical dimensions: smallest feature size one can pattern reproducibly. Clean room. What is clean room? So this is where we do our experiment to conduct a micro or the nano fabrication of the devices. It has multiple filters and a positive pressure. Okay, why? So that to ensure that there are extremely few particles that are greater than 0.5 micrometer. So that's why we maintain a positive pressure. Clean room are divided into classes based on the number of particles per cubic feet. These classes are 1 equal to 1 particle of size greater than 0.5 micrometer per feet per cubic feet, 10, 100, 1000, 10,000 and 100,000. For performing photolithography, the clean room also has a UV free lights. Okay, so the importance of clean room is very high when it comes for the photolithography process for the fabrication of the micro or the nano fabrication of the devices, or this kind of any pattern if you want to do the photolithography. So is it clear, these terms? What are these terms, or do you have any doubt? You can ask, or also you can unmute yourself and you can ask.
Sir,
Yes.
audible?
Yes.
The pressure you mentioned as
What?
positive pressure in clean room.
Yes, yes.
How we generate the positive pressure, sir?
Yes, so for to generating the this pressure, we have a pump there. So that's why that will create a positive pressure. I mean, there is an external source. So basically, that the objective of that having that kind of equipment or the pump is to create a positive pressure, so that your room should not contain any particle which is greater in the size. So that because during the photolithography, if the particle would be there, then it would contaminate your device. And once, because the device sizes are in the nano or the micro level, you can't even see with your naked eyes. So once it contaminate your device will fail and it won't work properly. So that's why it is very important. There is some additional features which can create a positive process to avoid the contamination in your device during the fabrication.
The value, sir.
Yes.
Value
Value,
for positive.
value that depends on the there are classes. Okay, so it depends on the how much that, like here it is giving one particle of a size like 0.5 micrometer per cube feet. So it depend on the class that what kind of a fabrication, so it varies. I mean, it's not very particular for every room. So if you want a very high, then it should be more and more. But if you don't want a less, then I like class one, class two. There are a different types of classes where you maintain a positive pressure. So there is not any very particular or the fixed. No, it depends on the work to work.
Create any impact on the size of the particles, sir?
Yes.
Pressure.
What?
The pressure
Yes, pressure.
create any impact on the particles, sir? The
Your
size of
voice
the
is not coming properly.
sir, the pressure it create any impact on the size of the particles, sir, in the silicon wafer.
Sorry, actually it's cutting. I mean, I cannot hear you properly. Can you please repeat again? Slowly.
But for the pressure maintained in a clean room, it
Hmm.
creates any impact on the size of the particles above the substrate, sir.
You mean the particle, how they maintain?
Yeah.
Yeah, so basically, I mean, see, when there is a big particle, so when you apply a pressure, so it won't be in
Mm,
the, yes. So basically here, I think I should say in a this way, that the positive air pressure, if I will say, let's say the room is having a positive air pressure. What does this mean? This mean is that the clean room are pumped up with more filtered air than the surrounding space outside the clean room. Okay, so basically the positive air pressures inside the clean room, normally it operates in an air pressure. So basically you can say that it has a particular, not very particular, but variation of the range. So that means, if you would say the particle or the contamination, that means if there is a positive pressure, then this room is more having a more filtered air than the surrounding space outside of the clean room. Okay. So basically the natural process is what? Air to flow from the high to low pressure. Example is that every day we see the wind are formed from the uneven heating of the earth surface, which generates the high and the low pressure air. Okay. So here, when air is moving in one direction, it's not moving in the opposite direction. When air is moving out of the balloon, there is not also air moving into the balloon. As long as the air inside the balloon is more pressurized. This concept can be applied to the clean room also, to stop the flow of air into the clean room. Get it or not? So the limiting particle transfer via the air and the maintaining a cleaner environment. Now I think it should be more understandable than the earlier. Is it clear or should I explain a bit more? Yes, clear. Can we go ahead? Yes. So the next one is your X-ray lithography. So do you know X-ray? What is X-ray? Yes. So by the name itself, it is clear in X-ray lithography we use X-ray. So in X-ray lithography, one uses X-ray to pattern the structure into a polymer. Okay. So here the X-ray will penetrate deep without any diffraction. So X-ray basically degrade the polymer due to their very high energy. And there are specialized X-ray resist. Okay, let's say a PMMA. X-ray masks are made of X-ray absorbing metal structures on X-ray transparent substrate. Process is used for making one master mold. Resist structure, then we do electroplating, then resist strip, then the metal mold. The combination of lithography, electroplating, and the molding is known as X-ray lithography. So this is not just the lithography, it's the lithography, electroplating, and the molding. Now, this is a German term which is an acronym for lithography. Okay. And the second one is your galvanoformer, F former. So LGA, LI GA. So this is LIGA. The technology was developed at the Institute of Microstructure Technology, which is in Germany in 1980s. So this X-ray lithography is performed at synchrotron radiation source, which are large circular facilities. Electron beam is accelerated in magnetic dipole, which cause energy loss in the form of X-ray. Okay, so did you get that how we do the sorry, not the X-ray lithography? Is it clear? Or if you have any doubt in the lithography how we do, then, or if you have any other doubt. Clear? So yeah, here basically in X-ray, if I would say this is your positive resist, okay, then this is your for the negative resist, and conductive substrate, this is your electroplated mode, okay. So when we use wavelength filtering for the various application here, and the UV lithography was developed as an inexpensive version of the X-ray lithography, okay, because this is expensive. Since synchrotrons are very expensive, synchrotrons are very expensive. I mean, it's not very cost friendly. X-ray synchrotrons in India, Indus 1 and Indus 2 are so it is only at Indore, only at one place, Rajaraman Center for Advanced Technology Indore, RRCAT. This is what we call RRCAT. So which is located in Indore. So if you want to do this synchrotron, you have to book a slot there, and it is very costly. Very. Now the next one is your in lithography, the nano imprint lithography and the hot embossing. So lithographic techniques can be batch or serial. In photo X-ray lithography, the properties of the resist are modified. In nanoimprint lithography, a patterned surface is used as a stamp and pressed inside the resist, which is hardened afterwards. Hardening could be due to temperature reduction or via thermal cross-linking. Large area patterns can be used, but not very high aspect ratio structure. Mold materials here should be inert, it should be smooth, and it should be high temperature resistant so the temperature cannot affect the shape and other properties of this material. Sometimes tapered for easy mold removal is also needed. You might have heard that how we do the tapered, especially when it comes to the casting. Okay, so Neal molds are fabricated by electron. Neal, it means nano imprint lithography. It is fabricated by your electron beam lithography, X-ray lithography, and others. After mold stamp removal, leftover resist is etched away. Mainly, this etching process is done by using a plasma. This process is commonly, and hot embossing are very similar techniques which nowadays use the same machine. Hot embossing is what? It is basically stamping a hot material and cooling it to solidify. Hot embossing was reported before this nanoimprint lithography, but are now merged because both are almost similar. UV nil is another variation where the resist is cross-linked by UV exposure. Okay, and the substrate is UV transparent. Types based on fabrication, plate to plate, roll to plate, roll to roll, there are a different. Okay, so as you can see here, this is a roll to plate, this is a roll to roll. Other variation, UV plus you can apply temperature, you can apply a laser, you can apply a electric field. Okay, optimization, what you have to optimize: thermal expansion, release of the solvent or the gases, resist viscosity, mold removal damages. Okay, so this is basically in a nutshell how the nanoimprint lithography is do. So we have done the normal lithography, positive and the negative, X-ray lithography, and this is a nanoimprint lithography. So now is it clear that how we do, or if you have any doubt, then you can ask.
I have one doubt on molding.
Yes.
The mold insert above the glass transition temperature of the substrate or the resist material.
Your voice is very, very unclear.
I thought that
Can you type?
more,
Can you type?
no, sir, I'm in outstation only.
Because your voice is like cutting. I mean, it's not very clear.
I post the question in message box.
Can you type
Oh,
in a
now
chat
I'm audible.
box?
Yeah, I posted that.
Yeah. How the mold is inserted above the glass transition temperature. Okay. How is mold? Okay. See, here we want ultimately this kind of a structure as you can see in the fourth. So our mold will be accordingly we will design. Okay. So this mold material should be inert. Why inert? It should not react with your resist or the any other material. Second thing here is smooth. If it would be smooth, then it would come a proper structure at the end product as a high temperature resistance. Now here comes your point, the high temperature resistance. Because here sometimes if we will apply a temperature curing, then your mold should not affect by size or by anything or any mean. So that's why it should have a high temperature resistance and sometimes tapered for easy mold removal. When you insert it, it can be easily removed. So your question is now how the mold is inserted above the glass transition temperature. Mold inserted above glass of which material, substrate or resist, which glass transition temperature. Yes, so definitely here it is talking about the resist, because here it is coming in contact with your resist, right? Not with the substrate. Substrate, we are taking a silicon wafer. Resist is combined with your polymer. So silicon is having a very high temperature. So you no need to care for this. So here it is mainly talking about the resist. Clear? Yes. So the next one is our activated carbon. So maybe have you heard about the activated carbon? Oh, sorry. Which are material used as mold? So it depends on the. I mean, the sometimes it can be made of metallic also, and ceramic also we can use as a mold. So it depends on the what kind of a shape and what kind of a resist you are using. And the other question you asked, how the mold inserted above the okay, that okay, yeah. So have you heard about the um, activated carbon? Do you know activated carbon? Yes, used in water, more absorption prop. So basically, um, So basically, in this activated carbon, the surface with physical and the chemical ability to absorb molecules. Molecules commonly absorbed on activated carbon are heavy metal ions, microbes, etc. Non-graphitizing carbon, you already know that I have taken it in our previous lectures, that what is non-graphitizing carbon and what is graphitizing carbon. So this is found by the charring mechanism are mostly porous. So by using this, you will get a porous, that I have already explained in our last to last class. So their pores have a fractal geometry. They are micro, meso, macro pores. Due to pores, these carbons already have the ability to absorb gases, liquid molecules. This is further enhanced by physical chemical activation. Activation typically generates a large number of micropores and increase the active surface area and volume. Generally, this char type carbons are activated, but it is also possible to activate carbon found by poking. So here you can see the macropores. If I will say, it is greater than 50 nanometer, mesopores 2 to 50, micro is 2 nanometer, or it could be less than that. So the activated carbon is the term used for carbons with an active surface and more than 98% elemental purity. Other materials found by charring at lower temperature may also have an active surface, but it has a lower purity. So here you can see some images at the bottom. Okay. Is it clear? Any doubt? Okay, yeah. So the next is our activation method. Okay. So in activation process, the first one is to induce the microporosity. So why? It increase the net surface area. And the second one is your adds active functional group on the surface. So there is two types of activation here. The first one is your physical activation and the second one is your chemical activation. So we will see one by one that what is there in the physical activation and what is there in the chemical activation. Okay. So in the physical activation, the heat treatment of porous carbon prepared at lower temperature so that the tar can be removed. Okay. Now here we heat, apply a temperature which is around 800 to 1000 degree centigrade, and this leads to glassification of some carbon from the surface. Here the water molecules diffuses inside the pores and block further gasification. In any case, some carbon is lost due to activation because here we are applying a high temperature. In case of chemical activation, it performed for natural materials such as wood, and also the dehydrating chemical is added to the wood before we do a pyrolysis to degrade the cellulose of the wood. Here some common dehydrating agents, which is mainly phosphoric or sulfuric acid. Now also we have some zinc chloride, metal hydroxide, carbonates of some metals. Porosity surface area measurement techniques are there because here we will get some porous. So how can you measure? Do you know any techniques which you use in your lab, or do you know, have you ever measured the porosity of your material anytime? Or have you heard about any technique which can measure? No. Okay. So here basically we have some gas absorption isotherms, mercury porosimetry, X-ray tomography, which is very well known by tomography. Let's say in X-ray tomography also we use X-ray just to scan 3D materials. So when you scan in a 3D level, you might observe that what is the porosity and is there is any porosity or not. So basically, to measure the porosity, tomography is very well known technique, and mostly people, and the result is also very reliable. Magnetic resonance and imaging, which is also very well known technique, as well as glass. Okay, so the glass like and other carbon materials are activated with relatively harsh conditions, or the chemicals, but they have closed pores, hence the this adsorbance does not increase much. Okay, so these are some techniques by using you can measure the porosity of your material or any kind of a shape, which is very feasible. Clear? Is it clear? So the next one is the absorption mechanism and the application. So first thing is, what is absorption? We are reading the adsorption. So can you differentiate between the adsorption and the absorption? These are two different, absorption and adsorption. Can you differentiate between two? What is the difference, basic difference? Yes, so basically in the case of porous carbon, the heat treatment, okay, surface absorption is held, yeah, which is right. Yes. So basically, in case of porous carbon, the heat treatment may sometimes be performed at low temperature because of its graphitic crystal structure, and are increased, the porosity might decrease, also because electrical property and the purity are less important. So basically the pore network is generally formed between the 500 to 600 degrees centigrade. Some pores are blocked by tar, which needs to be removed. Depending upon the desired purity, heat treatment temperature can be determined. Absorption mechanism is what? Single layer or the multi-layer deposition of the molecule of the absorbate. Here we use a hydrophilic functional group that attract the water molecule. Porous carbon are generally hydrophilic in nature. So here there are some types of activated carbon, such as powdered activated carbon, granulated spherical, impregnated carbon, polymer coated carbon, activated carbon fibers. So this is your absorption on activated carbon surface. This is how it goes. So yeah, these are some slides that which I which I understood. I hope this some concept would be helpful for your assignment solution. And one more thing, I have a solution for this question, but I would just ask you to try once from your side, then I will give you the answer. Here I have solved these questions in some slide. Let me just check. Yeah, here it is, the calculation of your UV dose. But this I will be discussing in the next class. Because I don't want to discuss, I want you to try here firstly. So here you have to calculate the UV dose for the resist film. Thickness is 5 micrometer and the energy for the photo initiation and cross linking is 140 and the intensity of UV lamp is 7.5. So please do calculate this UV dose and come to the next class. And if you cannot solve, then please let me know. I will try to discuss this into the next class. So yeah, that's all for today's class. So let's meet in our next class and we'll see some more numerical problems and some other concepts. Goodbye and thank you.